Assalamualaikum warahmatullahi wabarakatuh and very good day. So this is the speed control of a DC motor. Okay, so actually there are several methods that can be used to control the speed of the motor, which is listed here. We have three methods. The first method is vary the voltage supply, which is the voltage terminal, okay, supplied to the armature circuit while holding the field constant, okay, meaning that you adjust the V terminal, okay, to be variable, and the field, which is IF, is actually constant. Okay, the second method is vary the field current while holding the armature supply voltage, which is IF is increase or decrease, but maintain the VT constant. And the third one is insert resistance, which is in series with the armature circuit. Okay, so the first one is the variation of the voltage supply or the V terminal. So we have already learned, I think, series, shunt, and also separate excited DC motor. Okay, but for this method, variation of supply voltage, it can only be applied for separately excited DC motor. Okay, so for separately excited DC motor, based on the voltage, the circuit armature, so we have the VA or V terminal is equal to IARA plus EA, okay, from the armature circuit. And we know that RA is usually very, very small, okay, internal resistance of the circuit. So we can assume that your voltage terminal is actually equivalent to EA. And so meaning that we can calculate. So we know that VEA is equal to KT, K flux, omega, okay, while maintaining the field to be constant, meaning that you can control the speed by controlling the V terminal. Okay, meaning that the speed is Vt over K flux. Okay, so to increase the speed, you need to increase the voltage supply. So by using this method, variable the supply voltage and maintain the flux, you will have the torque speed characteristic like this. So this is for V1, this is for V value of 2, this is value number 3, and this is value terminal of number 4. So increasing the VT, so you will receive a new characteristic. Okay. This one is actually meaningful when you have the torque load. Okay, so this is the torque speed of the motor, and the torque load is actually, there are three types of the torque load. Okay, so we have a torque load that is a constant torque. This one constant torque is it's like an elevator, okay, lift, and we have a proportional, okay, and then we have the centrifugal or quadratic. So quadratic usually is referred to, for example, fan and so on. Okay. So for example, if you have the torque load like this, a constant torque load. Okay. So this is for voltage supply number 1. This is voltage supply number 2. When you increase, this is voltage. Maybe for example, this one maybe 100 volt. This one is 200 volt. This one is 300 volt, and this one is 400 volts. Okay. So if you have a voltage supply at 100 volt, okay, this is the value of the no load speed. Okay, when your supply is 100 volt, and this is your torque load. So the intersection between the torque speed characteristic of the motor with the torque load, with the load will give you the operating point of your motor. So this will give you the value of the speed. So this one is what I call the load, okay, and the torque, which is the torque motor must equal to the torque of the load. Okay, and for if you want to increase, for example, if you want to increase the speed, okay, what you need to do is to increase the voltage supply. So for example, from 100 to 200, so you will have the new characteristic, okay, has been shifted to this one. So the intersection between T load and your motor characteristic will give you the new speed. Okay, if we want a higher speed or speedier rotation, what you need to do is to increase the voltage supply to 300 volt, and it will give you a new speed. Okay, so every characteristic have their own no load speed. Okay, so if you choose 200 volt, so the no load speed is this one. Okay, and if you choose 300 volt, so the no load speed will be this one. Okay, so the speed regulation, as you can see here, this is the no load speed when for 100 volt. So this is the full load speed. So the speed regulation, as you already know, is actually equivalent to no load speed over minus the full load speed over the no load speed. Okay. So it is logic, okay, because when you have no load attached to your motor, your motor will rotate a very higher speed. But when you connect with a load, you can see that the motor will reduce the speed because of the weight of the load. Okay, so this is a very simple approach where you need to vary the supply voltage. This can only be applicable for separately excited DC motor. For shunt motor, this one is not very appropriate because, as you can see, the shunt motor is like this. The relationship, the connection. So this is your RF and this is your RA, which is this one is your IA and this one is your IF, and then this is your back EMF. Okay, if you make the VT to be a variable voltage, it will affect IF and IA. Okay, IF is not fixed. Okay, because in this method, IF should be fixed. IF should be is constant, should be made constant. But when you varies the BF, okay, the IF will also varies. Okay, the second approach is by varying the field current but maintaining the voltage supply. So as you can see here, this is the torque speed characteristic for a different field current. So we know that when the field current is increased, the flux will also increase. So this is for IF1, okay, and this one is when IF is equal to IF2, and this one is IF3, where IF1 is smaller than IF3, IF2, and IF2 is actually smaller than IF3. So if you increase the IF, okay, you will see that the slope will actually increase. Okay, so this can be applied for shunt connected and separately excited motor. Okay, but in series, this type of control is not appropriate. Okay, so I would like to mention also that for the first type, the variation of the voltage supply, it is separately excited motor and also for shunt. Okay, sorry. This is only for excited DC motor, not for shunt. Okay, only for separate excited DC motor. Oh yes, yes, also can. And because separate excited motor is actually equal to the shunt, so this one can be applied for separate and also shunt. Okay, and the second method, okay, so can be also applied for shunt and connect and separately excited DC motor. But for the series, this type of controlling is not applicable, because for series, you know already, this is your voltage supply, this is your RF, and this is your RA. Okay, and then this is your back EMF, where IF is equal to IA in series. So if you want to change IF, you will actually affect the IA also. So this is not appropriate. Okay. The third one, or maybe the simplest one, is by inserting resistance, which is in series with the armature circuit. Okay, for example, like this. Okay, so this is your RA. So you add another variable resistance. Okay, so when you reduce your RA, you will have a different what we call the torque speed characteristic of the motor. Okay, and also I would like to mention again here for resistance control. So it can be applied for all DC motors. For example, shunt, separately excited, and also series. Okay, and this is for the shunt, and this is for series. Okay, I think that's all for the notes, the pre-recorded video for this speed control of the DC motor. Thank you very much, and we meet again.